Today we're going to do a quick look back at the z-test that we taught for confidence intervals that we talked about yesterday, and some of the information about estimators, and then we'll go through how the t-test and the z-test are related, and then we'll look at how we use the t-test versus the t-test. So one of the first things that I told you yesterday was there are a couple things that I've already told you they're going to be on the test. And the first of those is the characteristics of a good estimator. So if I'm talking about a good estimator, there are three characteristics that it must have. So those three things that it must have is it must be unbiased, it must be consistent, and it must be relatively efficient. Now, if it's not any of those three things, then it's not a good estimator. So when we talk about a good estimator, we know that it needs to be unbiased. It can't sway one way or the other. It's got to be consistent. It's got to give me approximately the same mean. It's got to be relatively easy to reproduce, and it's going to give me about the same mean. We said yesterday when we used the z-test for confidence intervals, remember we said that as the percent goes up, the interval gets wider. And it actually becomes more easy to hit. It actually becomes an interval that can be used more often. We said that with the z-test, it has to be a normal curve. In other words, it has to be a bell-shaped curve. And my mean, median, and mode are always going to be in the middle. The mean is the one we're concerned about right now, but the mean, the median, and the mode are all in the center. And when we do a confidence interval, we go from the left and the right an equal distance from the mean. So this whole thing, if this is 90%, then that means that 45% of this is on the left-hand side and 45% is on the right-hand side. And we said yesterday, because of that, we have this notation. It's z sub alpha over 2. And that is a part of our formula. The 2 is because I have half on the left and half on the right. This tells me what I do with the percentage. Now, when we do z sub alpha over 2, we have three numbers that we have to remember. For 90%, it's 1.65. For 95%, it's 1.96. For 99%, it's 2.58. Okay, so for the z-test, when I do a confidence interval, there are a couple of things that have to happen. Okay, so when we do this, and let's just take a look really quick, we have, when we do a z-test to create a confidence interval, we know, first of all, that when we only use this when we have samples of 30 or larger. Okay, so if I have less than 30 in my sample, unless I'm just told that I have to use a z-test, I would not use a z-test. So we said yesterday that if I'm going to create a confidence interval, I have to have a formula. Okay, and that formula is mu plus or minus z sub alpha over 2 times omega over the square root of n. So basically what I'm looking at is I have the mean, I have the number that I'm given for z sub alpha over 2, my standard deviation, and then n is the total number of people that I talked to in my particular sample. Okay, so if we're looking at this, and I'm going to do a problem, and I'm going to draw the picture so you can see it a little bit better. Okay, so here is my bell curve. It's not real straight, but close enough. Okay, all right. So I'm going to do on your sheet on 7-1, I'm going to do number 11. Okay, now we said yesterday when we do these problems, we need 4 numbers. We need the mean, we need the standard deviation, we need n, and we need z sub alpha over 2. Okay, so we're going to look at number 11. Part A says what is the best point estimate. So the first thing we need to do is we need to read the problem for the mean. And it tells us that the mean is 82. Okay, so the best point estimate I have is this mean. So the answer to A is 82. It tells me that the standard deviation is 15. I had 35 fifth graders, so N is 35. And it tells me that I'm doing a 95% confidence interval. So go back to our list on the last page. On 95% is 1.96. So we're going to use that 1.96 right here. Okay, so for part B, it tells me that I need a 95% confidence interval for this particular problem. So I'm going to do 82 because that's my average or my mean, plus or minus, which in the calculator, that means I got to do this twice, once with minus, once with plus. Then I have my 1.96 times my standard deviation, which is 15, divided by the square root of 35. Okay, so now here is where knowing how to use your calculator is an advantage to you. So when you go to the calculator, and we'll clear this out, I'm going to type in my 82, and I'm going to start with minus, because minus is going to give me the left-hand part of my confidence interval. So I'm going to start with the minus. I'm going to do times 1.96. I'm going to open my other parentheses. 15 divided by the square root of 35. Okay, and you may have to use your right arrow to get the closed parentheses for that. And when I hit enter, I'm just going to round these off to 2 decimal places. This would be 77.03. So the left-hand side of my confidence interval is 77.03. So here's what I'm saying on my graph. I'm saying on my graph that the middle is 82. And over here on the left, I'm going to have 77.03. And the same distance on the right, now I have to find my plus number. So I'm going to have 77.032, because remember we have to have 2 numbers. Let's go back over here. Now, here's where knowing this calculator helps you out. You can do second and enter, and it puts that back on the screen, and you can go back to the left, change that to a plus, and that becomes 86.97. So 86.97. So where I'm going to stop over here is 86.97. So what that means is that 95% of my answers, if I redo this experiment of 35 fifth graders, 95% of my averages, when they come back, are going to be somewhere between 77.03 and 86.97. Okay, so I believe that the average of my experiment will be between 77.03 and 86.97 for 95% of the time. So if I know how to do this, I can get my confidence interval for these. Okay, so I'm going to do one more example, and that is number 12. Number 12 tells me that I don't know what the mean is. It tells me that I have a standard deviation of 0.62. I have an N of 36. And I have a Z sub alpha over 2. Tells me I'm doing 99%. So we have to go back to these numbers over on the other page. For my 99%, it's 2.58 right here. So this is going to be 2.58. Okay. Now I'm going to have to put all these numbers in the calculator. So I'm going to have to do stat. I'm on edit, so I'm going to say enter. And I'm going to put all of my numbers in the first list. Okay. So when I do that for all of those, I can do stat over to calc, and I'm going to do one bar stats, make sure I'm on list number 1. Now, this is not the data for this particular problem, but you're going to look for your X bar that's right here on the top. And for example, if you were not given the standard deviation, it would come from this line right here. Okay, so in this case, when you put all those numbers in, you're going to get an average of 2.82. Okay, so let's fill this in. We're going to do 2.82 plus or minus 2.58 times 0.62 divided by the square root of 36. And I should have two numbers, one for a minus, one for a plus, and that would be my confidence interval for number 12. That should help you if you have not finished your problems, number 14, 15, and 16 from yesterday's homework. The t-distribution that we're talking about today is related to and looks a lot like the z-test that we just talked about. So how is it like the z-test? The first way is that it is a bell-shaped curve. Okay, it is a curve where the mean and the median and the mode are all in the center. Okay, but remember, this is the guy we're worried about. Okay, it is symmetric about the mean. In other words, there's the same distance to the left and to the right of the mean. Okay, and it never touches the x-axis. Okay, so basically what we're saying is we have a bell-shaped curve and my mean, median, motor in the center. Okay, how is it different from the z-test? Well, first of all, it's different from the z-test in that you only use it for n. Sorry about that. That doesn't look like an R. You only use it for samples that are less than 30. Remember, I told you 30 is the magic number on this. Okay. Part of the reason for that is that the variance is greater than 1. Now, some of you like to see the mathematical symbols. So here is your mathematical symbols for variance is greater than 1. And then it is based on not one single curve, it's based on a family of curves. Okay? As the sample size increases, the curve approaches the normal curve. Okay? So basically what I'm saying is when I have a t-test, I don't just have one curve, I have a bunch of them. And they may be close to each other. Because the variance is greater than 1, I may have one that's not exactly right, but I have this family of curves, okay? When we have the family of curves, and we're talking about the t-test, now remember this is only for the t-test, we have what's called degrees of freedom, and they are the number of values that are free. That should be a small t, to vary after a sample statistic has been created or computed. They tell the researcher which specific curve to use when the distribution consists of a family of curves. Now, there's a couple things that you need to keep in mind. Degrees of freedom over the years have been abbreviated in a couple of different ways. And I think it's because we get lazier as we go along. It used to be that it was DOF, degrees of freedom, and it makes sense. Now it's just DF. Okay. As we've gone along and press has changed the way things are written, we have abbreviated things differently. So DOF and DF, both of those mean degrees of freedom. Now, how do we find the degrees of freedom? Well, this is probably the easiest formula I'll ever know, and it's n-1. So how many ever people you talk to, just subtract 1 from it. Okay, I want to show you the formula for the z-test and the t-test so you can see how they are related. Okay, for the z-test, we had the average plus or minus z sub alpha over 2, which was that number we had, over the standard deviation divided by the square root of n. Now that's the z-test. The t-test is the average or the mean plus or minus t sub alpha over 2 times the standard deviation over the square root of n. Now, both of these, let's do it in blue, both of these are the mean. This is the sample mean, this is the population mean. Both of these are the standard deviation. This is the population standard deviation. This is the sample standard deviation. So there is no difference in these formulas except for where we get these numbers from. And that's what we're going to look at next. Where do I get this t sub alpha over 2 number from? Okay. So you have a chart for the t values, and it's called a t distribution chart. And I'll show you the top of mine. It says the t distribution at the top. It should say table C. And so we're going to look at a couple of examples and go through these. Now, on the homework, numbers 1 through 3 came directly out of your notes that we just did. Number 4 are going to be exactly like the one I am about to do. So this says find t sub alpha over 2 value of 95% interval when the sample size is 22. So you need to go to that chart, okay? And I need to scroll down to the 22. I'm going to see if I can get it so that you can see the top also. Makes it a little easier. Okay, so here's what we're going to do. Get this so I can write on it. All right, so we need to go to, my sample size is 22. So my degree of freedom is 22 minus 1, which is 21. So I need to go to the line that has 21 on it. And then I need to go across on that line where it says 95%. Okay, so 21, 95%. So my number is 2.080. Okay, so I'm going to go to 21, go straight across, and here's my number right there. Okay, all right, so we're going to go right here, and we're going to write that, t sub alpha over 2 is 2.080 because the degree of freedom was 21 and my confidence interval was 95%. That is how you do number 4. Okay, so that should help you with number 4. All right, so the last ones we need to do are 5, 6, and 9. So let me go through and do number 10. Okay, I'm going to do number 10 on 7-2 so you can see it. Okay, so we'll go over here to the end so we don't have all this. Okay, so on 7-2, I'm going to do number 10. Okay, so on these, remember we said we always need the mean. We always need the standard deviation. We always need n, and in this case, we need t sub alpha over 2. Okay, so we got to read the problem. And from the problem, I believe on this one we had to put the numbers in the list. Okay, so let's do that. Actually, this is the one I had in here. So I went to Stat, Edit, put all my numbers in list number 1. Then I did stat, over to calc, press enter. List number 1 is highlighted because that's where my numbers are, and I'm going to calculate it. So I need the average from this right here. So I get 29.84. Okay, 29.84. That was my mean. Okay, so this right here is 29.84. My standard deviation was 6.18. My N was 19, so that means my degree of freedom is 18. So I'm going to look up on my chart, I'm going to look up 99% with a degree of freedom of 18. So I'm going to go back to my chart. So go over to your 18, straight over to the end over here. And you get, it's this one right here, so 2.878, okay, is our answer. So we get 2.878, okay. So if you want to draw your curve or that you're using, didn't do a very good job with the curve. Let's try that again. I didn't do a very good job on that. Let's see if I can draw a little better now. That's a little better. Okay, so my middle right here is 29.84. We want to know how far to the left and how far to the right I go. Okay, so I'm going to say the mean, which is 29.84, plus or minus 2.878 times my standard deviation, 6.18, divided by the square root of 19. Remember, that's N, it's not DF. Okay, we're going to put that in the calculator. Let the calculator do my work for me if I can. All right, so 29.84 minus 2.878 times 6.18 divided by the square root of 19. I don't know about on yours, but I have to use the right arrow key to get out of that. So I got 25.7, and this will be a 6 when I round it off. So 25.762. So if I'm putting it on my curve over here, it's 25.76. And then I need to do the same thing, only I need a plus. So I'm going to go over here. Plus. And I get 33.92. Okay. So 33.92. So my curve up here is 33.92. So I know in between these two numbers, 99% of my numbers will show up between those two numbers. All right, so on 7-2, you need to have completed 1 through 6 and 9.